All right, so if we're talking about the chemically formed organic rocks, or what you see on the chart as the crystalline for the texture, which means that the sediments are crystals. Okay, they could be all different sorts of sizes, and they primarily form as ions. Remember, we taught you guys about ions, right? The charged atoms that have lost electrons or gained electrons as they precipitate. What we talk about precipitate is basically the water gets too full and some of it starts to come out. The easiest way I can relate that to you guys is think of when you make like iced tea or Kool-Aid or something like that, and you just put in too much powder and it just starts to come out and collect on the bottom. That's basically what happens. You get water that has too much of a particular atom or mineral in it, and some of the crystals start to slowly kind of seep out of the water and collect down towards the bottom. Slowly over time, these layers of crystals are going to build up and up and up, and eventually you end up with a chemical sedimentary rock. The first example of this would be what we call chemical limestones, and these are basically going to happen when you get calcium carbonate, CaCO3, that's the formula that you see there, that precipitates out of solutions due to either the temperature of the water being too high or the concentrations being too high. An example of this would be dolostone. You can see it on your chart, on your reference table. Okay, it's listed there. It kind of looks like slanted blocks in the map picture, and this would be an example of a dolostone. You can see the image in front of you. Another way that you can get a chemically formed sedimentary rock is through the process of evaporation. This forms the type of chemical sedimentary rock known as an evaporite. An evaporite basically means that you have water, and that water evaporates, and it leaves certain minerals behind. The most common example of this would be rock salt. Okay, you can see it at the top of the chart. Rock salt is formed when you get ocean water, seawater, that evaporates, and it leaves behind large crystals of salt. You can clearly see the piles of them here. Okay, and you can see, the big swath. This is part of the Great Salt Lake, or what used to be the Great Salt Lake out in Utah. You can see those big white crystals. That's not snow, that's all salt. Okay, and in the picture that you're looking at now, this is inside of a salt mine. We actually find a lot of these in places like Sicily and the Mediterranean Sea. Okay, or the area around them, I should say. Okay, and so what basically happened is you had an ocean. That ocean evaporated due to some reason, and it left behind the salt in huge amounts. And so you were left with rock salt. This is the same stuff that, we spread on the ground during the wintertime. All right, so the next one we're going to talk about is rock gypsum. Rock gypsum is an evaporite. Okay, you can see it on the reference table. It's the second one on the lower part of the chart. And it's a soft sulfate mineral that's composed of calcium sulfite dihydrate. It looks like this. It's a crystalline substance, but it's relatively soft. It's also on Mohs scale of hardness. Here you can actually see a mine in Poland of gypsum. It's a very pretty picture, okay? And gypsum is used in a lot of different things, but one of the most common things that it's used for is drywall. So if you've got a finished basement or your house has drywall in it, you may, if your dad does something or your mom is in, to fixing things up in the house, you've seen drywall, like the pallets that you see before you. Those pallets are primarily made out of gypsum, so this is a very important rock that we use in every day. The last group of sedimentary rocks we're going to talk about are the bioclastic or the organic sedimentary rocks. And these guys, or girls, or non-gender specific rocks, are going to form from either the remains or the products of living things. So these rocks actually come from creatures that used to be alive and died, or something that creatures made during their lifetime, and that collected in layers, was compacted, was cemented, and eventually turned into a rock. Okay, the best example of this, the most common example of this, is limestone. Now, like we said, there's inorganic limestone, which we talked about chemically forming. Organic limestone is primarily going to form from the shells of dead creatures. Okay, it's going to form on, you get a beach where you get a mass die-off. Think about when you go to the beach and you step on the shells and they break into little pieces and they're already mixed into the sand. Now imagine this process happening over and over and over and over again. Eventually those pieces are all going to get massed together and they're going to form a type of sedimentary rock called an organic limestone. You can see the picture on the board in front of you, and it literally looks like just shards of shell that are stuck together, but this is an actual rock. The final bioclastic or organic sedimentary rock we're going to talk about is coal. And coal actually forms from the remains of dead plants. Plants that died millions of years ago that eventually turned into a rock. Okay, so you can actually see coal down at the bottom of your chart on your reference table, all the way at the bottom, what's called bituminous coal. There's a difference. There's different types of coal. This is the sedimentary rock. The sedimentary rock is called bituminous coal, and it comes literally, you can see on the chart, from compacted plant remains. Now, How does this process happen? Well, this process happens because what you start off with is a swampy environment with lots and lots and lots and lots and lots of plants. Now, this happened millions of years ago. And what happened is the plants died. And when the plants died, they sunk to the bottom of the swamp. The problem was there were no bacteria that could break down the proteins that were in the plants. They hadn't evolved yet. And so what happened is you basically got layer upon layer upon layer of just dead plant material building up, just like we talked about before. And so what happens? You get compaction. As you get compaction, you go from being something called peat, which is just kind of a soft, mushy material that if you dry it, you can burn and get a little heat and light out of it, to this thing called lignite. And if you keep burying it, you keep burying it, and you keep burying it, and keep more and more stuff on top of it, you'll keep squeezing the water out and squeezing the water out. Remember, it was a plant. It had lots of water in it. And so what ends up happening is you start losing water, and you're just left with carbon and oxygen. Okay? And eventually you're going to end up with what we call bituminous coal, which is the third picture that you see on the chart in front of you. Okay? And this is going to be harder and black. Okay? You can crumble in your hand. It makes your hand super, super dirty. Okay? And so we actually get coal from plants, which is why coal is referred to as a fossil fuel, which is also why it's really, really bad to use, because when you burn it, you're releasing lots and lots of what? Greenhouse gas. Carbon dioxide. Now, you can even take bituminous coal, which is a sedimentary rock, put it under heat, pressure, and stress, which is a process known as metamorphism. You see it on the board. And you can turn this sedimentary rock into a metamorphic rock. Now, we'll talk about that in a video probably after Easter. All right, guys? All right, guys, so that's it for the sedimentary rock. Sorry, I couldn't fit all into one. YouTube has this weird 15-minute policy, so I couldn't go over. I had to split into two videos. Sorry about that. There will be a homework assignment attached to this. Please make sure that you do it. Miss G and myself will be available for office hours on Tuesday between 1 o'clock and 2 o'clock. So please make sure you do that. Use the Google Calendar that's on the school site. You can find our office hours there. There'll be a Google Meets link. Come ask us any questions on the quest and things like that. And so this is the last video for what is on your test on Wednesday. Please make sure you watch it. I hope everybody's safe. I hope everybody's happy. I hope everybody's having a good Holy Week. And I'll see you guys soon. All right, guys. Stay healthy. Bye.